In this part of the series, we will begin by opening a new project file in Tekla Structural Designer. Once the file is created, we'll head into the design settings to configure our design preferences. It's always a good practice to define the project name, location, and units right from the beginning, as this helps keep everything organized as we move forward. With the project environment ready, the next step is to create the structural grid system. We'll be using the rectangular grid wizard for this, as our building layout is fairly regular. Based on the general arrangement drawing from the architectural CAD plan, we'll input the exact grid spacing, both horizontally and vertically, and apply proper labeling to the grid lines. Once that's done, we'll generate the grid, and our working base for modeling is now established. We'll then begin with modeling the RCC structural elements for the ground floor. Starting with the columns, we'll select a standard size, in this case, 200 by 200 mm, and place them at the key grid intersections as per the layout. Once the columns are placed, we'll move on to drawing the beams using the beam tool, connecting the appropriate columns to define the main structural framework. For this, we'll use typical beam dimensions like 200 by 450 mm, which can be adjusted later depending on design requirements. After setting up the beam framework, we'll proceed to model the slabs. These will be cast in place and designed later based on span conditions. We'll use the slab panel tool and define the thickness as 150 mm, drawing the panels between the supporting beams. Tekla makes it easy to ensure proper snapping and alignment, so the slabs are connected seamlessly to the beams. Once the ground floor structural elements are complete, we'll save time by duplicating this layout for the remaining floors. This ensures consistency and significantly speeds up the modeling process. Tekla automatically maintains the connectivity and element properties during duplication, which is extremely efficient. Finally, we'll switch to a 3D view to preview the overall model. At this point, we have a complete structural layout with slabs, beams, and columns placed on all stories, properly aligned with the architectural plan. This sets a solid foundation for applying loads and moving into analysis and design, which we'll cover in the next part of the series. Stay tuned as we dive into load application and combination setup in part 3. If you're following along, make sure to save your project at this point and take a moment to review your model visually before we proceed further.